Welcome to example number 7. Here we are looking at the function x to the square root of x plus 3. So unfortunately in this example, the log rules are not going to get rid of that radical as easily, because that radical when we take logs is going to come out in front of the log. Alright, I'll show you how this all works out. Notice also I removed the steps because I'm hoping at this point you have the steps kind of memorized, or at least you understand the process and how things go with these sorts of problems. It never changes. All right, first thing we do, we're going to set our function equal to y, as before. Okay, then we take natural logs of both sides. Nothing out of the ordinary here. Same old, same old. Okay, now we get to employ our log rules. So notice we have this exponent here. We're going to pull that out in front, the entire thing. So this gives us natural log of y. I'm just rewriting the left-hand side. Then we have square root of x plus 3 times the natural log of x, because the exponent on that x got moved out in front. Notice also very carefully that this natural log is not inside the radical. The radical is out in front of the log. Okay? So now what's going to make this tricky when we go to derive this is that we're going to have to use the product rule and the chain rule to handle this x plus 3 inside this radical. So let's derive both sides. Deriving the left gives you y prime over y. Now we need to derive the right-hand side. Deriving the first function. Now this is going to require a little bit of effort here, because note this is kind of like side work over here. Square root of x plus 3 is equal to the same thing as is equal to x plus 3 to the 1/2 power. So when we go to derive that exponent, that 1/2 gets pulled down in front, subtract 1 from the exponent, and you're done with the derivative of the outside. Okay? So deriving this gives us 1/2 x plus 3, because the chain rule leaves the inside of this radical alone, to the minus 1/2 times the derivative of the inside, which is just 1 in this case. So that derives the first part. That derives the blue underlined bit. This times 1 does not need to be here, so I'll get rid of it for the sake of space economy. And then as part of the product rule, I leave the second part alone. Okay? So this drives this leaves that alone. Okay? Now we're not done yet, because we have to add the derivative of the second, and where we leave the first alone. Okay, so continuing on, we leave the first alone, square root of x plus 3, and then we derive the second. So that gives us times 1 over x. So unlike the previous problems, we really can't simplify that, and we can't simplify that really either. So we're kind of stuck with what we got. So what we're going to do is put some big box brackets around this, because next step is what we always do, is we multiply both sides by y. Okay, so the y's cancel on the left, giving you y prime is equal to giant box of stuff to the minus 1/2 power times natural log of x plus square root of x plus 3 over x, because that's how fractions work, times y. But I'm going to skip a step this time. Instead of writing that y, I'm going to note that my y was equal to x to the square root of x plus 3. So that's what I'm going to plug in here. I'm going to have x to the square root of x plus 3. And we are done. Not really any way to simplify this at all, nor would I really want to. So that's it. I don't think you'd be asked to simplify something of this type. You'll usually just be asked to find the derivative, and that will be your final answer. Alrighty, so that was example 7.